guys, so in this video we're gonna talk about, well, a story from work and some appreciation that I have for typing systems. So let's get into it. So we're gonna touch on why I think types are great, why you should use them, and why TypeScript makes the world a better place, because I really do think that it does. TypeScript is the best thing since, I don't know, sliced bread. It's better than sliced bread. Not greater than pizza, but it's very close. So I'm going to walk you through a small story from work where basically I had a requirement. This was some time ago now, from our product owner. A product owner comes in and says, "Hey Frederick, we have this company who wants to work with us, and they have some very specific requirements on this system that we're going to build for them." And I go, "Okay, can we just walk through, like, what are the specifications?" And after a little bit of talking, I realized that, oh, this is actually, it's a pretty hefty specification with a lot of conditions and a lot of special custom logic. So we got to work, and I wanted to show you a method of dealing with all this complexity that is not so common in the JavaScript world. This specific implementation was not in JavaScript. I'm just porting it over to JavaScript, or, well, TypeScript technically. And the reason why this spurred in the first place was because I was working with my coworker who did the thing that is very common in JavaScript land, which is not as common in other languages, where he had taken a set of objects into the specification. Basically, we had some data that came in, and the job we had was to create an export with a bunch of logic that mapped some system data into a specific format that the external system was going to consume. And the way he had done that was with different helper functions, where he created a lot of different functions that validated if the data was correct, and he also made sure that, of course, he basically took in a raw JSON object or JavaScript object and had a bunch of helper functions to kind of validate that the data was in the correct shape. And the pattern that was emerging was that he was using these functions over and over and over to validate in different pieces of the system if the data was the thing that he expected. And so I told him, dude, maybe we should take a lesson from other languages, such as, say, C# or Java or something like that, where we have a slightly more object-oriented approach to this specific problem. And I know what you're going to say. I'm not saying that object-oriented programming is the best thing ever. I'm saying that for the thing that we were doing, it made a lot of sense, or at least I thought so. And we moved over to this way of to solving the problem in this fashion. It worked really, really well. So let's look at some data. Let's look at some code. So here, the basics of what we're trying to achieve here is that we have this object that represents some export data. Now, the problem with the export data is that it is a fairly complicated construct with a lot of business logic. Now, this is, of course, this is actual real code. It's a simplified version of the code. The real code was much, much, much bigger than this, but in essence, this is what it was about. So we had a bunch of fields and some data that needed to be converted into, I believe it was an Excel sheet, because everybody loves Excel for some reason, or something like that, or CSV format, whatever. And so what we needed to do here was basically to create to combine a bunch of different data sets into a specific format and validate that that format was correct before we could actually export this information to the external system. So originally we did the thing that most people would do. We created a bunch of, we had some raw objects that came in from the system, and we had some functions that just kind of put everything together into one single JSON object. Now, or JavaScript object. Now, the thing that I was suggesting to my friend here, to my coworker, was that let's actually leverage the class system. And I think that the same thing is true here in TypeScript. And I just wanted to show you kind of how we approach the problem, because I don't think that there's all that many people who would have thought about this in a TypeScript environment. So we created an interface, simple as can be, which just includes the different structures that we need in order to actually hold the data that's going to be required in order for us to process this into the export format. And then we created this little constructor here where, well, we just allocated the name, the IBAN code, the desired start date, and the current provider code. Now, what's interesting about this is that instead of having a function that basically just takes a dumb object that is an untyped object of whatever, we've actually created a type for the thing that we want. In other words, if all the code that consumes this export data class can be guaranteed that it has all the things that it needs in order to trust that the instantiation process of this object has been correct. That is the contract between this type and the rest of the system. But in the original version, we simply had a object that we were promised, like we just had to know that all this information was actually part of that object. But that's where I was saying to my friend, because instead of having all these functions that checks that is named correct or that the IBAN code was correct, we could have, instead of putting all that logic in multiple places in the entire system, we just created a class that once it has been instantiated, we are guaranteed that all the things that we expect are actually true. So here, as an example, get current provider code, which is in this scenario, it's just something that takes a provider name, which is just a string now, and it goes to a map with a bunch of special numbers that maps from one thing to the other, which is part of the specification. This is really ugly code. I think it's ugly, but it's part of the requirement. So of course we're going to have to unit test this. We're going to have to do a lot of extra work in order to make sure that this is the case. So we really want to scope down the possibility of this thing being incorrect, and we don't want this to mutate into the entire system, because all this logic here is specific logic that exists within that external system. So if we can encapsulate all of this ugly logic into this type, our system has an interface. It has an interface that it needs to just consume instead of having to know how to do all this mapping and all this other stuff. So this thing here becomes, well, the export data class. It becomes the interface. It becomes the interface between our system and the external system, a mapping layer, if you will. And so all we did was that, all right, let's create a constructor which takes in all the stuff that we need, and then we can do all this internal business logic, such as this. And then we segmented it even further. Now we could have just put all of this validation logic inside of this one major export class, but this is the beautiful thing about a type system. Instead, you don't have to work with always work with primitives. I mean, even this thing here. The reason why the name is just a string is because it doesn't require a type, because it could be, there's no logic associated with it. But the IBAN code, let's look at that. So the IBAN code, the interface for that is that, well, the value of the IBAN code is a string, because at the end of the day it is just a string, but we wrap it in a type because it is a string with semantics attached to it. The name could be anything. It could be, we're basically saying that this could be any string, but the IBAN code has a type because of this, it has logic, it has associated business logic. So the IBAN code in this specific scenario, it could only be exactly 16 characters long. And it also needed to not contain any, I think this should say spaces or dashes or minuses or whatever. So it basically had associated business logic with it. I hope that makes sense to you, because if we had just made IBAN code a string here, we would have had to, in the constructor, we would have had to validate all this logic as part of this thing here. But just as with the export data, we create a constructor class where, as long as that takes care of that validation for us. So instead of putting all of the validation logic inside of this constructor, we just add another level. We know that if we're getting an IBAN code, we are guaranteed that all of this has already happened. So we don't have to guess. We don't have to double check it. We never have to validate things more than once. Because as soon as we have an instance of an IBAN code class, we know that we've checked all the things that we need. And this is where I think this is very elegant, because it just continues being valuable as long as you so that if you just add a type, you can remove a lot of the guesswork that goes into working with only primitives. Because if you're just working with strings, you either have to just cross your fingers and hope that some other logic before you has validated that this string is correct and that it didn't change in some unforeseen way on the way down to your piece of logic. But if you have the type, well, then you can trust that. And this is just, I mean, for me, this feels fairly intuitive because I'm used to working this way in other languages. It's just not so common to see in JavaScript and TypeScript. And then we had the desired start date, which was another data type. I mean, this could have just been a date, because technically it is just a date. But the problem here is that it's actually more complicated than that, because in the specification it said this. So it could be a date, but it could also be a string, because when we were exporting this information, it should either be the date string or the string ASAP. In other words, we want this thing to happen as quick as possible. And then we had other logic that was associated with it, where if the desired start date must be at least 30 days into the future, but it cannot be more than 365 days into the future. All of this business logic, which is just pure logic, could now be encapsulated in this type. And we could at the same time extract the values that we actually needed. And I think this is very elegant, instead of having a bunch of functions that operates on only a primitive. There are absolutely situations where you want to do that, but I think that you should really consider this approach when you're dealing with something that isn't really a primitive. You think it could be a primitive, but it has all these rules attached to it. So instead of creating all these helper functions that needs to be called in multiple places inside of the code base, because as I said, you don't really know. If you're dealing with a primitive, anything could have happened or anything could have changed along the way until it got to your specific function that is going to do something. If you just wrap that into a type, you are guaranteed, more or less, that all of this logic, all these checks that you need to do, well, they've already taken place. You don't have to worry anymore, because you're not dealing with a string, or like you're not just dealing with a date or whatever. You're dealing with a desired start date, which is a type that wraps that primitive. So what I want you to take away from this is that I'm not saying that object-oriented programming is the best thing ever, but this is a practice from OOP that is very common in languages like Java and C# and other languages as well, I'm pretty sure. And I think that it is something that you should consider even when you're working in JavaScript and in TypeScript, because TypeScript ideally, of course, because there you actually have a type system. But instead of always working with primitives and having functions that checks and validates and does all this other logic, and where you need to make a lot of assumptions on that primitive that you're dealing with, try to wrap it in a type, or try to wrap it in a data structure, a higher level of a data structure. You can do it in JavaScript as well. It's easier in TypeScript, of course. But try to do that, because you can capture so many bugs and so many misses in logic and regressions and so forth if you just wrap your business logic inside of type. And try to keep it segmented. If you're in React land or something like that, you know how to deal with components. Instead of creating one super component that contains everything, try to segment it. This thing here is just a composition of a bunch of fields with different types of data. So instead of creating an export data superclass that knows all of the ways that you can, how to deal with an IBAN code or a desired start date, just add another layer, add another type or another class that takes care of the validation of each subsegment. That way you can really, really just laser focus in on one specific piece of the data that you're dealing with. So an IBAN code or a desired start date, and then compose it together to an export data type that actually does all the things that it needs to do and validates everything in the correct fashion, but it does not have to have the knowledge of how to do that in one single superclass. I hope that makes sense to you, and I hope that I've inspired you a little bit to consider the next time that you're thinking that, oh yeah, I should just make something a string, or I should just make it a number or a date. Really think about it. Is it really a string? Is it really just a date? Or is there some business logic that you would like to add on top? And if that is the case, consider wrapping it inside of a higher order type. Have a great day.